Okay. Hello, everybody. It's my pleasure today at 6 p.m. To welcome Anouk Wipprecht for the keynote on AI and fashion tech. Mika has come with me from the previous session in order to help me for the Q&A session. And Anouk, I will introduce you and then let you the floor. So you are a fashion tech designer. You create designs ahead of your time, combining the latest in science and technology to make fashion an experience that transcends mere appearance. You want your garment to facilitate and augment the interaction we have with ourselves and our surroundings. Your spider dress is a perfect example of this aesthetic, where sensor and movable arms on the dress help to create a more defined boundary of personal space while employing a fierce style. Partnering up with companies such as Intel, Autodesk, Google, Arduino, Microsoft, Samsung, Adobe, Adidas, Cirque du Soleil, Audi, Disney, Swarovski, and 3D printing companies shape ways you research how your future or our future would look as we continue to embed technology into what we wear. And more importantly, how this will change our perspective on how we will interface with technology. Thank you so much, Anouk, to have accepted the invitation. And I'll let you the floor now.
Perfect. Thank you so much, for the invitation as well, and a great speech, Mika, just before mine. Nathaniel already said wonderful stuff about me, so I hope that I can show you some visuals with that as well. If correct, you can see my screen. If not, let me know. So you can find me if you have any questions afterwards. You can put it in the question screen of the Zoom, and otherwise this is my my tag where you can find me as well. So my research is about if and when we put technology on the body, what does it do? And in specific, I work a lot with sensors, so with body sensors and also sensing the surrounding in the immediate distance of the design. So you can see here the intimate, the personal, the social, and the public space. This is from the proxemics theory of Edward T. Hall. In the 60s, he was doing a lot of research around personal spaces. And people have different culturally and person to person, they have different spaces. And he was measuring that out with an analog stick, like a wooden stick sort of, you know. And he was writing about it. One of his books is The Hidden Dimension, that he wrote a little bit about it. And these spaces have been questioned, but this is a little bit the basics of proxemics theory, which you can see here in a diagram. So basically I took in the halfway 2000s, I took his research, and I instead of measuring it with a stick, I was starting to measure it with digital sensors, so ultrasonic rangefinders, proximity sensors, heat sensors, and cameras. So how that's going to look like is this, for example, you see it also behind me. This is the robotic spider dress that I created when I was working at Intel in 2014. It had a former version in 2010. And then when I was working at Intel, I had the opportunity to create sort of a fully 3D printed robotic version out of it. But this dress is utilizing proximity sensors. So they're in the front of the design. So you can see them right here. There are two proximity sensors, ultrasonic rangefinders, and they are measuring that distance. And when somebody steps into the personal space, the dress is reacting, it's attacking, which you can see here because it has little motors, little servos in the shoulder pieces. So here you can see it a little bit on the on a little movie. And it's not just reacting in one way, it's reacting in different ways. Otherwise, it would be quite boring. So depending on how you walk up to this stress and how you're interacting with it, it reacts faster, which is funny for me because I take it to other countries and other cultures, right? So I see that in the data, but I also see that in the action. So if I present it in America, everybody's more an elegant distance from the design. So it's not super freaking out, or it's not really going in a super aggressive state. But when I'm taking it to the Netherlands, where I am from, people are much more, yeah, sort of quicker and more closer by, sort of, you know, much faster. So that is determining that the stress is also much more aggressive when it's actually being presented in the Netherlands, which is kind of funny. Sometimes with my designs, I like to hide the components. Sometimes I like to show them. In the case of the spider dress, I definitely like to show everything, because for me, it's about education, especially when I sometimes work with children. I want them to see where all the sensors go, where it all goes in, where the battery goes, and all of that stuff. Because for me, it was an, yeah, kind of an education notion to see that all wired outside of the body almost. So one of my other dresses is the Sensoric smoke dress. So this dress is also based on sensors. It reacts differently. It has a different interaction. This one is based on the octopus, or the inktvis, how we say it. It pushes out ink, so it can basically escape, and that is a little bit the notion of this dress. The dress has sensors, and other than sensing person to person, almost like the spider dress, it senses who is in the direct surrounding of this dress, and based on that, it starts to smoke. So the more people surrounding this dress, the more it starts to smoke and put up this smoke screen. It is almost like the feeling of determination with a spider dress. The smoke dress is definitely more an emotive, a more almost like shy design, I must say. So it's all about like working also on certain emotions when you're designing for certain behaviors that these dresses have, almost in this input and output situation of the input being the sensors, the body sensors, the surrounding sensors, and the output being whatever is happening from robotics to smoke and everything around. Like this dress, this is a robotic cocktail dress. So it's a dress that really makes you a cocktail, as simple as that. It does it through a peristaltic pump in the back of the design. And I created this design when I was collaborating with Cirque du Soleil. We were looking at sort of food experiences, and I wanted to create a series of dresses that could do things with food. So here you can see the peristaltic pump in the back. She's pushing a button, and basically the drink is being created. So the restaurant is called Heart, and it's in Ibiza, and these dresses walk around there serving drinks. So what I mentioned before, what I am researching is I'm researching that if and when we put technology on the body, basically what does it do? So how can it become more social, more playful, like the cocktail dress, more defensive and behavioral, like the spider dress, and more expressive and emotive, like the smoke dress, for example. And really seeing fashion as this new kind of interface. I think myself, I started when I was 14 years old with fashion design, couture tailoring, women's wear. I got pretty good at the construction of garments, but I got into the fashion field because I love that fashion is being able to express us. It's being able to communicate something really personal about us by the things that we wear. So I got into fashion design studies, but as I was in there, I refer it to the analog stick of Edward T. Hall, you know, that he was measuring things with. For me, garments were analog. They were not doing anything. If I put on a flower dress in the morning because I feel happy, I might not feel happy in the end of the afternoon anymore. I'm still wearing that flower dress. So how can these garments almost go about that? You know, how can they change? So when I was 17 years old, I decided to look into another interest of mine, which was robotics and mechanics. And for me, the robots had the heartbeats and the brains that I wanted my garments to have. So when I was 17 years old, I started to combine basically wearable robotics with the fashion designs that I was making. And ever since I've been doing that for about, I must say, like 18 years in total, almost 20 years. So there was quite some time. Definitely in the beginning of 2000, there was not easy to use technologies. There were like big computers. So a dress looked nice from the front, but you turned around and there was this really big computer on the body, you know. That's definitely not something that, yeah, that you want, sort of, you know. So I think what really changed that were people like Arduino, for example, you know, making like smaller boards for us to use and more easy, digestible, like programming language and all of that stuff. And I think because my designs were so out there, pretty early on, making my own way of fashion tech, sort of a lot of companies got interested in that. So I have been doing yeah, many collaborations with companies that Nathaniel already told you in the beginning, and I'm still doing that. And it's really cool because you are working together with a company on a certain case study. You know, you want to tackle something. It's a design challenge or an engineering challenge or something like that. And it's really cool to work like that with companies and brands and also other collaborators. So one of the collaborations that I did was for Audi. They had a new car, the A4, and they asked me to create some designs based on that. So I took that really literally. I took out the parking sensors of the car and the headlights, the LED-based headlights, and I put that in the dresses, and also making the dresses based on the manufacturing techniques of the car, which was like 3D printing. We even sprayed the pieces in the Audi garage. So they were actually really spray painted, how you spray paint cars, sort of, you know. And in that process, you're looking a lot at, yeah, what can we do for interesting things around that, from things that move. Was basically this projection map dress. It's polygons based on the car. And I was like, we were trying to like live map on it while the models were walking around. So how that looked like in the end. And for example, the Audi project was really an interesting project, I think, where my identity, the style sort of, you know, and also their DNA was really mixing well together. And I think that's something in the end that you're looking for. Either your identity or your things are not mixing and you're trying to find that in a project, or it's already mixing. There's already some design elements or case studies or design challenges that you can then collaborate on, sort of, you know. So it's always something diverse. It's always something different, almost collaborating, sort of. I'm also collaborating with yeah, people like Victoria Modesta. She's an bionic pop artist, and she's an amputee. She lost her leg yeah, a little bit earlier on in life, and ever since she has been creating really awesome like prosthetic legs and really making a name for herself to be advocating in such a new way in this whole scene of differently abled bodies. So a lot of the work that she does is about transforming the body and working with the body. I had the pleasure of working with her for the last few years on some collaborations, which is one of the ones that you can see here is the smoke leg. It's a leg based on the smoke dress. You almost step in it and this smoke appears. As also for Art Miami, this is a project called Sonifica. She had an accelerometer in her leg, and while she was moving, she could make music, and she was interfering with that with these tusks, this design that she has above it, as well as some other things for her stage shows, like this one in Paris. And a recent project that I just wanted to name out was kind of this really cool engineering marvel, because I had the idea of true friends of mine who work with Tesla coils, architect, to put a small Tesla coil in her leg and make almost an electricity effect later on, which we defined as like a Jacob's ladder effect. And the shoes were made by United Nudes. Here you can see the little Tesla coil. It was all like really beautiful. And then you can here see the leg with the car. So it was part of a sort of fashion movie for Rolls-Royce, their new car. And basically what I wanted to do is take the void space out of her leg. So she was really standing only on those little side parts next to it, sort of, you know, and then create this technological marvel. The circuit was in the heel of the shoe, then going to the Tesla curl, being moved up to her leg, sort of. So yeah, from things from like stage to like, yeah, working with companies on more research related things, beta testing, I do a lot. I also work a lot with body signals, and that is a little bit a topic that AI comes most about, sort of. So yeah, if you're talking about body signals, you can measure a lot of things from the body, from the head area, EEG to pulse to EMG, like muscle contraction, EDA, pH digits, galvanic skin response is really cool. Respiration, so the way we use our lungs is really interesting for emotional data, I think, whether heart rate and heart volume is very rational. Respiration is almost very organic, sort of. So it's really interesting, I think, to work with that to detect certain kind of, yeah, to get closer to detecting certain kind of behaviors and emotions. Accelerometer, like the place in space of your body parts, like I did with the leg of Victoria. Heart rate, heart volume, and also temperature, and also the environmental sensors that you can see around it. So in terms of like data and sort of data mining and sort of predictive analytics, we did a project with Intel in 2013. It was for Intel Developer Conference, and I wanted to make a dress and then have the model basically walk around, in this case, the show floor of the Intel Developer Conference, and that we would be able to measure her, like almost her stress levels and what was going on using yeah, computer vision, using a little camera in the front, using the proximity sensors to detect people in her direct surroundings or whatever was happening around her, and also how the body was reacting to that, measuring her stress level. So that was based on the Intel Edison, and you can find, this is, you can find a movie online. I'm not going to show that right now. I hacked an yeah, commercial NeuroSky. It was a brain, a BCI, brain computer interface. It's for me more NeuroSky. Definitely at the beginning years it was a little bit more EMG, so yeah, muscle contraction, how we use the frontal part of the head instead of what I was really after was focus, which normally you measure more in the back of the head, sort of, which I will tell a little bit about later. But yeah, it kind of worked out. Data was kind of fuzzy of the EEG, but the rest worked out: heart rate, respiration, all of that stuff. So basically, and this is not the like the graph, it's just an illustration. The idea was to see her stress level, see how her body is responding, see what is happening in her direct surroundings by the camera, and also see who is interfering her space or what is interfering her space, and then correlating that to stress levels. So while she was walking at certain events and like walking around, we were measuring that. That was kind of a really cool project in really like understanding and working with body data and stress levels and figuring out a little bit like sort of, yeah, that entry point into all of that. I had later on, I got the opportunity to work as an artist in residency at Ars Electronica. And instead of making a dress, I wanted to make a device. And in specific, I want to make a device to work with children in an, yeah, setting where the children yeah, are experiencing ADHD. So I started to work on that, and it became in the end Antiaging Unicorn. So you can find this project online. So this is an yeah, project that is dear to me, because I think if you look from the pharmaceutical side, a lot of children are getting medication when they're pretty young, when they're really young, sort of, you know. And I don't think that that's always really good for a child to go into like, yeah, heavy medication when they're pretty young, because it changes a lot of their behavior almost, you know. So what I wanted to rethink was the notion of like creating a device in order to tackle some of the more sort of brain awareness kind of stuff, in where you might become more aware of yeah, the things that are happening around you, and that the things that are happening around you have an effect on you, which with ADHD is yeah, mainly sometimes a problem that there's just a lot of things happening. You do notice that if children get to understand a little bit more about how their brain works, and that was what I was hoping to do, that they would be able to calm themselves down in different ways instead of using in the first term like heavy medication, for example. So yeah, some of the redesign, like the design work, was like placing a camera in on the head, in this case a unicorn horn, because I think medical devices for or experimental medical devices for children should also be playful, and we'll let you a little bit know about that later on. But this was the first stage of Aging Unicorn. I mostly created a device. This was without the sensors, and then I basically tested. And sorry to cut there. The main thing that I want to always test out is like going in stages. What can the device see? Computer vision. How can I work with that data? In the hardware sense, what kind of lens does it need to see certain things, or does it need a light when it's dark? All of that stuff. I was working with, then the next thing is the electronics technology, working with the dry electrode system of these the sensors that stick through the hair that make the contact. And the main thing that I did not want to work with was it's called a 1020 system. It's 64 electrodes on the head, because I think working with a child, with a doctor, it's not super comfortable for the child to be in, especially if they need to wear this whole headset with all these sensors. So it's not comfortable for them. It's also not necessarily comfortable for us as sort of data researching side, because the child that is in that situation might be scared, or like not exactly knowing. It's not its playful self almost, you know. And you want to have a child in their own playful state, how they normally are when you, for example, measure them, because otherwise it's not super true to data, sort of. So one of the big challenges was to make, to use less electrodes. So this is how we got with the company GTech and neuroscientist team to the P3 Wave P300 for the ERP, if you're into neuroscience and EEG. And this is, basically with this P3 wave, we could measure the focus. So that's basically in the back of the head. And I could also easily translate that back to this headset, basically. So those are the 8 electrode points that of the P3 system that I ended up using. So here you can see some of the system design and the headset design. Design of the horn, and then this is the design in the exhibition setting. So basically from a prototype, which looks like this, going into that is almost like a product kind of situation. And then we also had the pleasure to, with GTech, that they could bring out this system. So they rolled with that. It's called Unicorn BI. You can find it online, and we use it as a research and a development tool. There's also an hackathon connected to it, Brain.io hackathon, and it's going virtual. So if you want to know more about EEG, it's free. You can just come and join. It's inspired by Aging Unicorn, but it's going to be in spring school in April. So you can look on the website. It's Brain.io. You can find the dates. And if you're interested in anything around EEG, you can go there and basically participate in the school, which is 10 days, and you learn a lot about all of this. So last year, then we had the opportunity for Ars Electronica again to work with GTech and YKU, who at that time developed a 1024 brain-computer interface, and they wanted to collaborate back with me. So often you see these things as an input and an output situation, in where you have the sensors and whatever you're collecting in data, and then the output in this case is the fashion piece, is the sort of the stuff that is happening around and on the body. So in this case, I wanted to create a dress that had a direct connection to all those 1024 channels that we are measuring through 64 electrodes on the head. The models did needed to be having a shaved head, but we're measuring over 64 electrodes. Each PCB has 16 sensors. Connecting those 1024 channels to the dress was kind of hard. So I chose for both using light LEDs using also movement, so little servo motors, and you can see them all in this within this dress. It's called the pangolin dress. So they were moving in the end. When there's a more meditative state, the whole dress became purple and more glowy, flowy. When you're in a neutral state, it's blue, more pulsing. When you're in a hectic state, the whole dress became very hectic, blinking, flickering, and all of that stuff. So it's kind of cool because you could really see the sort of whatever was happening in the head of our models, in this case Daliette and Maggie. So the dress went into publicity. Somehow some things picked it up. They said this dress can read minds, and in the first time I was a little bit offended by that, but in a way it does sort of, but I think the real hero is here the technology of the 1024 BCI, because that brings you a lot, especially if you're thinking about the neuroscientists community and the field of neuroscience. The more we can know about the brain, the more we can sense about the brain, the better solutions we can make for other medical things like stroke rehabilitation. And that's not what I do. That's not necessarily what I do, but I think that's really important for the field, that such sort of experimental developments are happening. So to end my talk, also, open source, making and sharing with your community, I think is really important, whatever you do, if you're busy with AI or making stuff. GitHub to me first, hexo.io for hardware. So if you're not necessarily super into the electronics now, please pick it up, buy an Arduino, get into any of these websites, research it. It's just, so much fun. One of the big things with AI is like the entry point. If you do not work with data, it can be really hard to get into working with data, sort of, so the easiest way is buying a heart rate sensor and then sort of piece of hardware and look that up yourself. There are some things on Instructables that you can find, light up kitty ears, and there's also a lot of places that you can find your electronics and start with that. So I'm gonna give the screen back to me and Mika, and I think the last part of the talk we're gonna do a little question and answer, and talk a little bit about this field and our respective knowledge in the.
First of all, Anouk, thanks so much. I mean, it's now official. You're one of the coolest women I've ever met before. It's insane what you can do. You have to understand, for those people that can't see a full room, she has like a 3D printer, she has like a cutter, she has everything. It's mega cool, honestly. Congrats on your presentation and your realizations. I think we have, you're honored to be able to listen to you for 1 hour. I also love the fact that you are able to take us between your neurobrain trainings that you were giving just earlier today when I was pinging you about the questions. You're like, I'm in a training, I'm doing neurobrain training. I'm like, wow. Okay, this is fantastic. So thanks so much. It's a pleasure. I hope to meet you live next time with your dresses or a couple of people so we can see it, how it really works. But then you're using your videos give us a good impression. So I have a couple of observations. So you talked about, how you can implement AI within your work. What are the open opportunities you see that if you would look towards the future? What are the opportunities you still see for AI?
I think as we work more with sort of wearables and especially garments or the things that I do, right? We are having much more points of data that we are actually connecting stuff to our body and our surroundings, what you see with me. So I have to deal a lot with data in where, for example, the spider dress, it reacts at it reacts at a moment, but it maybe not store because it's just a direct action reaction kind of thing. But like Aging Unicorn, for example, it examines and it analyzes, and then it also like responds, right? So that's a little bit more maybe the case of like sort of where you implement AI, especially with EEG. And all of these devices, the more they learn from your body, the more they can do with things, right? So that's always the funny thing, because I'm in between a whole thing about privacy and security, because I be secure. But then from, it's basically putting two hats on. From the designer, I say, okay, protect at all times, privacy, security, and all of that stuff. But from the research side, from that side, I want to know as much data as I can, right? I always say that artificial intelligence or with machine learning, it's almost like a hungry monster. And the monster is really hungry and it wants to have as much data as it can. But then, of course, you also need to think of like, yeah, where is privacy and all of that stuff. I think especially with this kind of stuff, if we have all these systems that we need to understand the body and to recreate certain things with that, a big thing that always comes to mind is, oh, what happens if all this data comes to the insurance company, right? A lot of people are afraid of that, for example. So all this body data, your insurance company might know that you're not as healthy or you don't move as much. And I think like, yeah, those things are, the more you work with that, the more reality becomes that such things can become clear. And I don't think that that's the thing that we want, or that we want to do with the work that we do, sort of. So like, where is the balance between that, sort of, you know, and what are rules and regulations about that? And there's more and more that people are starting, that we all start to talk about that and all of that stuff. But definitely like events like this are just really important to talk about, like these possible futures, because now we are still able to shape them, right? Also in your talk, what you talk about the potentials, but also the current problems. And that is not the doom scenarios, that is more the things around cultural, social, ethnical norms. Those things are much closer by than most of the people think. If they think about AI and doom scenarios, it's like, oh, the robots take over. It's like, well, no, but we have other problems. So I think, especially with working with wearables, there's a lot to talk about, and a lot of discussion that needs to be done still in this field.
Yeah, excellent. And indeed, about the cultural differences. I mean, you're a traveling lady. Yeah, you work in Florida. Sometimes you work in Europe. Can you talk about the differences you feel at that level? You know, and on the privacy, do you feel that difference?
Definitely, if you work, I try to not work with cameras as much as I can. Actually, most of my designs are based. Antiaging Unicorn, I need to work with a camera because I'm doing, if I do things of facial recognition and emotion detection, sentiment analysis, you might want to use a camera because it's a little bit easier, but it also makes you lazy, right? So when I work with a company, sometimes you talk about invasive versus non-invasive, in where invasive technologies might be a camera and recording anything that happens around you, right, at all times. Non-invasive might be like, okay, I need this data. How can I get it, but maybe without using that camera, right? Yeah. How can I use proximity sensors to get my data? How can I use thermal sensors to get my data? How can I just listen to things? So I think you can always, as you always need to think of that stuff. But definitely me and also people that I know that work with cameras. There are different laws in America than there are in places in Europe or in Asia around cameras, for example, and especially if you have a multimedia artist, or if I work with a company, I would always suggest like, okay, there's this thing going on and you're being recorded with a camera and all of that stuff, handing tickets out. I see some people do, but it's not the most elegant way, because it takes a little bit off from the sensation of what is happening in that room, sort of, you know. But I do think that, working with cameras, I would say can be more invasive than working with other kinds of sensors. So I would always support and stimulate people to look in, different ways that they can sense and get their information than they might do with current state of cameras, sort of.
Okay, so it's interesting. You know, in my talk, I talked about the energy efficiency. Do you see that as a complication, or do you see like there are possibilities in the future to have a look at that part as well? You know, do you see this as a complication in your designs at the moment?
Energy, well, we have big things around like just energy without having, if you're placing like batteries on the body, that's always a topic, of course, you know. So it's more from the hardware side. I think that we are looking a lot at like what kind of batteries can we use. You don't want to really use LiPo batteries. I mostly use like rechargeable batteries, but I would love to use things like solar or kinetic energy. I mean, we're all walking, you know, but that's a little bit far out still. So I think it's more like that we look a lot at implications in regards to really the hardware of the building new batteries that are organic, that are around. Not necessarily in like AI solutions, but definitely like, that can be an interesting part as well.
Yeah, sounds interesting for the future. So this week was all about AI, and we also looked at, you know, the political tension on AI that we have around. So how does that implicate your AI, your design? You know, the tension that there is around AI from a political point of view, the plays that are, you know, the games that are played and so.
I think humans and machines, like, we both learn different, and I think that's where most of the problems and solutions also come. I think a lot of the things are modeled after investigating human behavior and finding a way to use that. In my work, actually, I use a lot of looking at animals instead, right? Mm-hmm. From an behavior point of view. You have a field called biomimicry, which looks a little bit more at processes, but I do see that there might be a lot of interesting just behavioral things, and that's what I kind of like, where AI, a little side field, it's not really big, but the sort of the biomimicry of AI is going to, because actually looking at social settings of animals and all of that stuff. Sometimes with AI, we look too much as at humans, how we do things and how we model, because we think we are the super minds. But I do think that animal intelligence has a lot of interesting potential and solutions that, first of all, have not really been researched in so many course. But I think, sometimes I'm more going towards that notion of looking into more different ways of looking at it. But I do think that the more like AI we have as tools to use, sort of, But again, we also need to, of course, make agreements and discussions about it as we use them.
Yeah, it's a very interesting point. Our Prime Minister this morning, he was also mentioning like the augmented intelligence, where we could extend the human intelligence with things that we are unable to do, which is like, coming from the animal area, or even plants, that's an area which we haven't discovered at all, because plants are not moving, so we think they're stupid, but in fact, they hide a lot of information for us. So now, if you think about, what impact can AI have, on the aesthetics of your design in the future? Can you say something more about that from, things that you've been reading that you would be dreaming of?
With AI, basically in design, if you're doing anything with 3D modeling, you're talking about generative design. So a lot of design you can calculate based on certain restrictions, which is, of course, interesting. It goes a little bit out of your hands, because how much is the agency of the designer versus what you give out, sort of, I think a designer sometimes always still wants to have a hand in that, instead of making it totally go rogue, sort of, But definitely, like, generative design is really interesting from the design point of view, letting things calculate based on certain parameters almost. I think if you look at it from AI and fashion, I think there always needs to be a hand in something, sort of, especially if you look at maybe emotion detection, and a lot of companies come to me and they say, oh, we want to have this design that is based on emotions and that does this, and of course they say, and it needs to be this small because you need to wear it. And I'm like, okay, first let's go back. First of all, we cannot really reliably detect emotions yet. That's a kind of a lot of people think that and say that, sort of, second of all, definitely not that small, but that there are solutions. You can say, okay, you can measure fight or flight through EDA, you can measure focus through the brain, if you make that all connect together, but it will be like an exoskeleton around your body. And that's kind of the cool thing. What I think about garments, they can have all those sensors embedded, because brain needs to be, of course, measured here. EDA, this is a good place. Galvanic skin response, your hand palm, respiration, basically your lung, almost like a band, or however you want to do that. HRV, your heart region. But it is a thing that you need to let all those points listen to each other. What is the brain doing? How's the skin responding? What's the temperature? And it's this thing. And often with emotion detection, still there's this question, hey, I detect this, do you really feel that? So there's always this sort of the question that you send back, sort of. But I do think that, as we do more with this, we are able to connect multiple body signals with each other. By that, we can measure or get a little bit a better sense of using emotions in there as well.
Yeah, and that's an interesting point, because indeed, for people that are less good in expressing themselves, this might help them to extend, to the communication. It's another form of communication. So when do you think this is going to be, commercially included into our fashion? Like, even if it's on small parts like rings we wear, because I'm quite impressed with the rings you are having, or like in the dresses. So when do you see a future for this, or do you see this commercially coming up in the next 3-5 years, or?
Definitely. What I always say is technology came into our lives to help us, but does it these days? Because, for example, if I take my phone, I can just sometimes a heart attack from all the messages, all the notifications, because this piece of technology is not listening to my body, right? So that is something that I'm really interested in. These pieces can listen to your body. They can take you in consideration first instead of the device, you know. The way we have been creating devices is because of the technologies that were available, but that changed the last 10 years, 20 years. That has been changing sort of, yet our devices are not necessarily, you don't see that big change between the symbiosis between the body and the device almost. And I think that is where fashion tech and these sensitive garments and emotive garments basically come in. I think you can create a new wave of devices or technologies that can actually listen to your body instead of pumping you with information almost.
And I mean, it's data that you're creating with your garments right now, and it's going to be increasing. So are there any interests out there, you know, or people interested in, analyzing your data, or, you know, they like researchers working with you on analyzing the data and getting these emotions out, or how does that work? How can people collaborate with you?
I only use data if I really need to. If I can fix it in other ways, like the spider dress is not collecting any data. If I have to collect data, I don't want to collect data. That's not necessarily something. If you're working with a device or a solution like EEG, you do need to collect data and you need to analyze it to make certain predictions maybe. So it all depends on, do I need to make a prediction, or can I solve it basically in another way, using closed loop or using whatever, or in what parts do you need to use machine learning, or at one point, deep learning and all of these things. So in some projects, I'm using sort of machine learning sides. In other projects, I do not want to use it because I also want to have projects out there that can live on their own without maybe working on that. So again, it's all about the invasive versus the non-invasive, and I think it really depends on what you want. Sometimes you want too much data, but do you need it? And that's always important to think with yourself. You know, if you can sense the world, why would you? Because that's a lot of data mining, and data mining comes with a lot of data. And what are you doing with that? Sort of, you know, so that becomes often absolute. So only use it when you really need it. Basically, that's always how I would say.
I think that's a nice message. Don't collect data because it's technically possible, but use data if it's going to solve a challenge. Yeah, exactly. That sounds very good. Now we see an enormous pickup of the use of radar compared to image, you know, for gait detection, for gesture recognitions, even for privacy concerns. If you want to observe a person, you know, you can do vital sign monitoring with it, etc. What do you know, if you could dream of the new data types or the new sensors, because it's basically what it is. What are the ones that you would come up with in your priority for the next years?
I think specific to certain, that's actually a good question, like specific to the certain things. I think your, the visible light versus the thermal enhanced example from the Tesla car that made an accident in your talk, sort of, you know, in where you can use the current technology, or you can really make something specific. So I think it always, now we're using technologies really broad, but I think that we will see more custom to a certain need, technologies being created, not just because we want to make a product, but because there's a need for a really specialized kind of technology. And so I think like there's it's hard to answer that, I guess, but I think. There's a lot of like just interesting things that are more taken globally or first for a specific purpose and then created to be for the consumer market almost, you know. I think like because we have such a good access to electronics now, a lot of more people will start to make their own solutions, their own sensors and all of that stuff. And that is something that you see, especially the last 10 years, which I think is really cool also in the do-it-yourself field and all of that stuff, that people might not want to wait for this piece of technology coming out. They can actually create it themselves because technology got so small and also much more affordable than like 20 years ago, sort of. And I think that's kind of a really cool field that people just always make their are not
exactly.
status quo, and they start to develop their own technologies.
So one 3D printer in every home in the future, you know. So I'm also looking at the questions that are coming in because you talk about the design itself, and one of the questions that comes in is what about being collaborative with Iris van Herpen? I understand. I looked her up. I think she's a fashion designer. I just need to that age that I really need to make sure that I got it right. Yeah, Iris van Herpen. I looked her up. She's a fashion designer. I don't think she has electronics in her dresses from what I see. But so I think we can open up the question more general. So have you had requests from fashion designers worldwide or from designers in general for collaboration?
Iris, she's from the Netherlands. She does a lot with like materials, maybe less robotics, but she did do some collaborations with roboticists and artists that work with like robotic elements, not necessarily AI, but I think Philippe BC and some of the others, but I think especially from like fashion houses, I think there's a lot of interest in this. I think I always say there's a few things to figure out yet. One is maintenance. So if you get one of my spider dresses, it breaks in the evening. There's something like a light can break, right? Any piece of technology can break. You cannot wear that dress in the evening. So what do? Do you send it back to me for repair? Do you go to the city for a robotic dress repair person? Or are you witty enough to do that yourself, to repair it yourself? And this is why I'm always super interested in the do-it-yourself community, because if you break something, you can build it yourself, sort of. But definitely, like maintenance is important, which is also really dependent on manufacturing techniques. Other than this is a really extreme example, the spider dress. I mean, I don't see people walk in that right now, but I have some other designs that are fabric, that are washable and stuff. But yeah, what is the notion of maintaining the pieces? The second one is washability. Because as you know, the biggest concurrent of electronics is water. So how do we go about that? But the cool thing is, and that happens, there's this big conference in where washing machine companies come together and they figure out the next future of washing machines. And I do know from those places that people are working on the next generation of washing machines that might not use water. So that's really cool and that's really interesting, but it stays in laboratories, it stays in their labs. It's not something that we can use right now, sort of, so definitely things need to come like much faster out of these laboratories for us, and then the last big part that we already talked a little bit about is energizing, of course. The batteries that we have to use now are those made for us. We have the body, which is organic and round, and we need round shapes. We might need flexible solutions for kinetic energy. So I think washability, energizing and maintaining, like those are still a lot of things that that are out there that we are sort of having open conversations about. But if you look at it, this field is not that long ago, it is for maybe 10 or 20 years or something like that. So for that to trickle down, but definitely there's a lot of interest from things like people wanting me to build exoskeletons to solutions that they want to have in handbags for the fashion industry, so from a lot of industries, there's a really big pool and a really big interest in all of this. So,
it's quite amazing what you're saying. I mean, the washing machine competition, that's if you're not in that field, you wouldn't even think of that. It's fantastic. It's wow. Now let me, because I look at the time and maybe as there's not a question coming in, I'm going to ask my favorite question, because it's a question that I didn't answer in my book because I simply don't have the answer. It's also how I ended my previous presentation, is you have the thing on creativity, and there's this endless debate if art and creativity, if AI, what AI creates can be called creative, and you can have a very subjective personal answer, and it's no good or right. But I would like to have your opinion, as like you're a designer, you're tech, you're very good in technology. How do you look into this? If this question is asked.
I think it comes from the old sort of thing. I think like if you talk about creativity, about art and science are both doing things with basically investigating the world around them, sort of, so they have basically sort of the same core in that. I mean, I think that the nicest thing is that we don't have to put things in boxes anymore now, you know. You need to study this or that, you know, you cannot do both. We are becoming really hybrid animals almost, you know, in where everything, sort of seeps together. And I mean, that has been, going on for quite a long time because of artists and scientists and all of this stuff. And art is often inspired by science, and science is often also inspired by art. So I think it's more of a collision than a division almost, you know. I think always like it can inspire each other. Engineering work is inspiring a fashion designer, who inspires a cook, who inspires somebody that builds houses, you know. I think like we should stop with necessarily like thinking in all these boxes, you know, because we only make restrictions. In design, restrictions are good, you know, and in other things like you might want to break that a little bit more open, sort of.
And I think that's it's a very nice way to finish this question round. It's because it comes back to how we started the day with the Prime Minister, who said we should break down the silos. I don't think he immediately thought about your dresses when saying so. However, it is true for all types of things. If we want to make sure we prepare the future in a correct way, you know, collaboration and breaking down silos is absolutely key. How can I thank you, Anouk? This was very inspirational. I could continue for hours with you, you know that. I would like to thank you very much. We're very much looking forward from European point of view to your next, designs, your next, creations. We hope to see them live next year. And thank you again. And I'm going to hand over the final word to Nathaniel for finishing the session. Thanks a lot, and very much appreciated.
Thank you.
Nathaniel, do you want to conclude, or should just checking? I don't think that Nathaniel is available. Oh,
yes, I'm here.
Yes, sure.
Sorry, thank you so much for your presentation, Anouk, and for the discussion. It is the first time, no, it's not the first time you are presenting something in Belgium, huh, Anouk?
No, at Kik from Marie, I presented, and quite a few other things.
Yeah, that is so great to welcome you, in any case, and hope we will do it physically next year for the European AI Week. And the interaction was so great. So we have recorded all. We will, if you agree, we will post it and put it on YouTube. Now we have several debates on AI adoption within the Belgian hospital, and we will have a debate on the brain and the difference between artificial intelligence and human intelligence you would be interested in. And tomorrow it's the European AI Day. So many countries are coming in the morning to discuss the collaboration we can have within Europe. We will have also a keynote or the presentation of the new book of our Google CEO from Benelux, Thierry Geerts. Some presentation on the possible funding from the European Commission, and also a dual keynote from Frank Delart. You may know him. He was in Carnegie Mellon and now in Georgia Tech, and Luc Van Gool, who are international experts in computer vision, working with autonomous car or drones. And at 6 p.m., please, if you can, join us for the closing ceremony. It will be 30 minutes. All the speakers and all the attendees are welcome, and we are preparing some surprise. So it has been so great to have you, and hope to see you in Brussels or Paris or in the Netherlands or in Los Angeles, why not, soon. Thank you.